Hey, it's Matthew Todd and welcome to the next lesson in Module 5. So in this lesson, I want to dig a little deeper, cover some slightly more advanced details, cover some of the more subtle changes to your test implementation that you might come across when using testing for purpose in some more complex systems. So I'm not going to cover the standard list of TDD anti-patterns, because I think many of them are symptoms, not causes of many problems I see, which I think can be addressed using the techniques we've already talked about. So in this lesson, I want to focus on test doubles and talk about how these are often misused and how they should be used instead, which is especially important when using testing for purpose. And this is a slightly longer lesson as we will go deep into more technical detail, but I think it's worth going through this to avoid some of the common mistakes I see people making with test doubles. And they can really cause your test code to be more brittle and harder to maintain. So before looking at some code, I want to go over a few definitions, as I see a lot of misuse of the terms out there. So, firstly, what do we mean by a test double? So the term test double is one that a guy called Gerard Messeros came up with. I hope I'm pronouncing his name correctly. But it's a term used for something you would provide to your system under test that's a replacement for a real implementation that would normally execute. Now, whilst there's no body or organisation providing official definitions of these, his definitions are pretty much accepted. So individuals such as Martin Fowler, organisations such as Microsoft will also use these definitions. So test doubles then, as we said, they are something you would use, something you would provide to your system under test. This could be as simple as a replacement function, or a more complex implementation, such as a replacement class or interface implementation. These test doubles can serve a couple of different purposes. Broadly speaking, they'll do one of two things. The first is relating to verification, verifying method calls, function calls, etc. that have taken place. Make sure they were called with the right parameters depending on the scenario you're testing. And this is also called indirect output of the thing you're testing. So it's not a return value from a method or function that you'll need to assert on in your test code, but it's something that happens when the system you're testing is asked to perform an action. The second type of thing that a test double can do for you is to provide input to the system you're testing. So we've already talked about test boundaries, such as what we mean by a unit when we perform unit testing. In most applications we test will be retrieving information from elsewhere. So it could be a service call, it could be a database, or any other kind of external or internal system. Now, in order to not bring these systems under test as part of a unit test, we would usually provide a test double of some form that, rather than talking to these systems, would act as if that had really happened. So it provides some kind of response to the code being tested instead. These test doubles will be providing data to the system under test, and this is often known as indirect input. So it's input that's not provided directly to the function we're invoking from our test code, but it's important input that our test or system under test requires. So you have an understanding of the rough categorization of test doubles that we can have. Now I want to talk about the different types of test doubles that can exist within those categories, some of which I'm sure you're already aware of. Now, I'm not going to give an exhaustive list here, but I want to cover the basics, as I think people often get this wrong. And the types I'm not going to talk about here are actually just verifications of the ones I'm going to go through right now. The first type of test double I want to talk about is a stub. So this type of test double is one that provides indirect input to the system being tested. So these are things that would, for example, provide a canned response to a service or database call to provide some known input to the thing we're testing. There's no logic in the stub implementation of a function or an interface. They just return some known data. So it could be entirely hard-coded, or perhaps data that the stub accepts on construction. Stubs are really simple, but for reasons I'll come to in a minute, they're something that I think are actually underused. The second type of test double is what I found to be the most commonly used one, and that's the mock. So the official, if you like, definition of a mock object is one that's used for verification, for verifying the indirect output of the system you're testing, and it does this by first allowing you to define the expected interactions with this object. You would then provide the mock object to your code, maybe as a parameter to the function you're calling, or maybe on construction. The way you replace dependencies in your code depends on how you've implemented it. And depending on the details of the mock implementation, it will likely be verifying behaviour as methods in the test doubles are executed. You might also be able to make another call to your mock to ensure that there were no unexpected interactions with the mock object. The exact details will depend on the frameworks, libraries and tools that you use, but the important thing here is that mocks are very different from stubs. They're used for setting up expectations before the action relating to your test is invoked, and then you can verify that the expected interactions of your code actually did happen as your code is executed. Now, part of mocking a method call may well result in you being able to specify what the mock implementation of a function should return, but this is not its primary purpose. Do not use mocks purely as a way to return data to the function or code that you're testing. That's what stubs are for. You might think that you could or should use mocks this way, given they provide this ability sometimes, but as a side effect of this, they'll also be verifying application behaviour every time a method is invoked on them. And the result of this, if you do use mocks in place of stubs, you'll have many places in your test code that are actually indirectly verifying the same behaviour, which violates our principle of testing for purpose, which says that we only want to be testing a single specific piece of behaviour in any given test. Each test would then be verifying multiple things. And the same behaviour, the same interaction with the system we're providing a mock for, that will be verified in multiple places in multiple tests. And this is going to make a test brittle and very hard to maintain going forwards. Any change in application behaviour would cause multiple test failures. Any change in that part of the code will require fixing many tests. And the default mode of a developer, when faced with that, as we talked about in Module 3, when we discussed refactoring, it then switches to just making that pile of broken tests pass. The meaning and purpose of each test can get lost when we do this. If the difference here still doesn't make 100% sense, then don't worry, I'll show an example in a minute of what this looks like in practice and how you can avoid it. But first, the last type of test double I want to talk about is one known as the fake. The fake is a bit like a stub in that it provides indirect input to your system under tests, but it's probably got a more complex implementation. As the name suggests, it's a fake implementation of an object, but one that behaves in the right way. So a classic example of this is a fake implementation of a database. So you would implement whatever interface you have defined for your database operations, and could, for example, provide a really simple in-memory implementation of this interface. So probably just using private fields or something in your fake implementation to store objects that you request are inserted into your database, and modifying these in place when asked to perform updates, etc. So it's something that will behave as a real database would in the context of your test, but without relying on external systems being there in the right state and all of the overhead that would entail. Okay, so that's quite enough talking about definitions. As I said before, I think most people go overboard on mock objects. So whilst different types of test tables might look similar, I think it is important to remember the differences and to avoid overuse of mocks, because they will make your test code much more brittle, harder to maintain, even though it might not seem like it at the time. So now I want to show you some code to illustrate the different types of test doubles in action. So for this example, I'll show some code that I've created for this, but it's 100% representative of something I see every day. I'll show you a couple of tests from part of the code base for an imaginary application that takes some sales data from an online store, stores it in a local database in a form that we can use for various types of sales analysis. So this part of the code base we'll look at the tests for is responsible for synchronizing the order data. It retrieves order information from our external platform, in our example Amazon, translates it to a format application understands, and stores it in our local database. So it's a simple integration kind of workflow, something I see in one form or another all the time. It could be order data, it could be customer data, syncing from a CRM like Salesforce for instance, but the workflow is the same. So this is a very simplified form of what this code base would actually look like. In reality, there'd be more interfaces, more methods on the interfaces, but this is entirely representative of what this would actually look like in a production application. It's just a subset of it, that's all. So looking at the first example test, this is a test that's verifying that when we request that all existing orders are synchronized, a request is made to Amazon to retrieve all orders. It sounds simple, but this is the first step in syncing orders, actually requesting those from Amazon. In reality, there might be different parameters we could pass here, such as time limits, order ranges, etc. But keeping it simple for now, as that's not important for what I want to focus on. So looking at this test, the unit under test is the Amazon Order Synchronizer class. As the name suggests, it's the class responsible for syncing Amazon orders. And from a dependency perspective, it needs to be constructed with two dependencies. The first is a reference and implementation of an interface that allows it to request orders and other data from Amazon. The second is a reference and implementation of an interface that provides access to our database. It's our data access layer. So in this first test, we are verifying that when we ask the Amazon Order Synchronizer to sync all orders, the relevant request is made to Amazon. So here, as far as our test setup goes, we don't have any class level test setup, as we want fine control over the dependencies the Synchronizer class uses in each of our tests. As I said, this test is for verifying that when we ask the Amazon Order Synchronizer to sync all orders, the relevant request is made to Amazon. And here, because we're using our strategy of testing for purpose, this is the one and only thing this particular test method should be verifying. So the part about storing the retrieved orders in the database will come later. So for this version of the test, we're using a library called EasyMock to generate a mock implementation of our Amazon client interface. So you can see here in the test, we're setting up our expectations in the mock object. We expect the getOrders method to be called. We then put the mock into verification mode, and also call verify at the end to ensure there are no unexpected interactions with our mock object. So as per our definition of a mock we talked about before, we're using this to verify the indirect output of our synchronizer. The other dependency, the database, is not a mock though. Here we're just using a simple stub implementation, which we'll look at in a minute. The important thing for this particular test is that we only have a single mock, and we're only using it to verify the retrieval of orders. For comparison, I want to briefly show you a version of this test implemented using Mojito. This library also allows mock implementations to be generated, but rather than having to record replay semantics, as with EasyMock, it works almost like a stub, and the verification method calls is explicit and takes place after the execution, rather than being an inbuilt behaviour of the mock, which means that expectations are set up beforehand, as we saw. I think it's important to see the difference between these two approaches. So whilst EasyMock is a more traditional, purer form of what you call a mock, Mojito provides both mocking and stubbing behaviour. So moving on to our second test. This time we're calling the same method on our synchronizer class, but we're concerned with being able to verify that for each order retrieved from Amazon, an order is stored in our own database. Note that we're not concerned with how the data is translated. There will be a separate set of tests for this. This particular test is just ensuring there's a direct relationship between the number of orders retrieved from Amazon and the number of orders inserted into our database. So in this test, we construct our synchronizer as before, the two dependencies. The difference in this test is that this time, we provide a stub rather than a mock for the Amazon client implementation. So we're not interested in verifying any interaction with the Amazon client because we've done that in the other test. So we absolutely 100% should not be verifying this in two places. So we should not be using a mock for this implementation. So instead, we provide a stub that will return some known data when getOrders is called. We do, however, provide a mock implementation for the database class. This again is used for verification. So you can see in the EasyMock implementation of this test how we set the expectations as we did with the last test, and then ensure that the verifications happened. The right methods have been called with the right parameters. For comparison again, here's a Mojito version with explicit verification that the method calls taking place after a code has been tested has been executed. So on the face of it, these two tests have a lot in common. Both of our test methods are invoking the same method on the class that's under test. The dependencies we provide to it are different though. Sometimes we use a mock implementation of a given interface, other times we use a stub. And this is driven entirely by the behaviour that we're trying to verify. So following our strategy of testing for purpose, we have different tests for each piece of behaviour, hence needing to select between mocks and stubs even for the same interface in each test. This is based on the behaviour that we're trying to verify. So the main piece of advice from this lesson is select the types of test tables you use wisely, based on the specifics of the test you're writing, and also the test frameworks that are available to you. Something like Mojito might allow you to auto-generate stubs and mocks, but just be very careful to ensure you're not using the mock features when you shouldn't be, when you should only have a stub. Something like EasyMock makes it more explicit, as it only provides traditional mocking behaviour, not stubbing, which is why in the first examples we saw the implementations of our stub objects. Note that if you are using something like this, then you may find yourself wanting to use mocking features to verify one method call in a class, but for other methods you require something more like a stub again, and this is again because you should only be verifying a single piece of behaviour, and using a mock implementation for every method call would introduce additional verification in each test method that we wouldn't want. So in this case, you can have a class like this, which implements the interface of your dependency, but allows us to delegate specific method calls to different implementations of the same interface. So here you can see that the default behaviour is to use a stub implementation, but for the insert order method call, we are using the mock. So we're using the mock implementation in order to get the ability to easily verify the method call has been taking place, and it's been called in the way that we want it to be able to. It's been called in the right way. So we're using the verification features that the mock library provides for us here. This is a technique I wanted to show you. You may or may not need it, as I say, depending on the libraries and the test framework features available to you, but it's one that I think is important for you to be aware of, so that you don't compromise on writing your tests using testing for purpose, even if the test tools you're using only provide traditional mocking features. There's always a way to ensure that each test is verifying a single specific piece of behaviour. Okay, so I'll leave it here for this lesson. I know it's been a bit longer, as it's one of the more technical lessons in the course. I've also provided a repository and source downloads for the examples, so you can see this for yourself. Spend a little more time if you need to looking at the differences between the tests. But I hope it's been useful to dig a little deeper into how we actually go about writing the test implementations, aside from the structure and mindset we've already talked about. So sticking with our strategy of testing for purpose, it means we can be very precise with the selection of different types of test doubles that are available to us, often using different types of test doubles for the same real interface within the same set of tests. So I'll leave it there for now, and I look forward to seeing you in the next lesson, where I'll take a step back and talk about how to introduce testing for purpose to both your new as well as existing projects.